Hence, in this problem, we are given a quadratic equation mx square plus 2m minus 1 into x plus m minus 2. Now, when this quadratic equation have rational roots for which integral values of m, for what integers of m, this equation will have rational roots, right? Now, we know for a general equation like ax square plus bx plus c. What are the roots? Minus b plus or minus under root b square minus 4ac by 2a. We know these are the two roots for a quadratic equation. Now we want these two roots to be rational. Okay, what that means in rational, we closely observe this part. This part is under a square root. Okay, so then this part has to become rational if overall roots have to be rational, because this is equal to minus b by 2a plus or minus under root b square minus 4ac by 2a. Okay, this is anyway rational. This part is in the form of p by q. This is anyway rational. This is rational is dependent on this numerator, which is square root. So for example, if this is irrational, square root is irrational, then whatever is the denominator doesn't matter, this becomes irrational. Right, this will become rational only when the numerator is also rational. So overall roots, which is sum of this part and this part, if both are rational, then only our roots are rational. Otherwise, even if one of them is irrational, it will become irrational. For example, 2 plus or minus root 5. Then this becomes irrational. Right. So b square minus 4ac should be a perfect square. Then only this part will become rational. It can be 0 or it can be any perfect square. Right. Then only this becomes rational. Now, here m is an integer first of all. Okay. Here in this case also, these roots to be rational, this one b square minus 4ac should be greater than or equal to 0, and that should be perfect square. Okay, the square root of that, this number cannot be a rational number. Right. Now here let us apply that same thing. B square minus 4 into m into n minus 2. B square is 2m minus 1 whole square minus 4 times m minus 2. If I expand this, 2m minus 1 whole square, what is that? 4m square plus 1 minus 2ab minus 4m minus of 4m into m, that is minus 4m square minus and minus plus 4 into 2 8, 8m plus 8m. What will this become? 4m square, 4m square will cancel, 8m minus 4m is 4m, and this one is 1. Okay. Now 4m plus 1, m is an integer. Okay. So and this part should be a perfect square. Okay, m is an integer, and that means 4m plus n is also an integer. So that means it is, if it has to be perfect square, it has to be a square of some integer. Right. Let us assume that integer is k. Okay, 4m plus 1. This is an integer. Should be k square. K is also should be an integer. K also should be an integer. That's fine. Okay. Now what does that mean? 4m is equal to k square minus 1. Okay, we are taking this one to the other side, which is equal to a square minus b square, a minus b into a plus b, k minus 1 into k plus 1. That means m equals k minus 1 into k plus 1 by 4. Very good. And m is an integer. The denominator is 4. That means automatically the numerator should be even. Otherwise, odd by even will not be an integer, right? If m has to be an integer, the numerator should be a multiple of 4, and definitely that means these two should be even numbers. Okay, these two should be even numbers, because k minus 1 into k plus 1. It cannot happen that one is even, one is odd, right? For example, if k will take some number like 2, then k minus 1 is 2, 1, and k plus 1 is 3. 1 into 3 will be 3. This is odd number, right? If you take some k as some 5, then this becomes 4 and 6. 4 into 6, this is two even numbers. Okay, k minus 1 and k plus 1. What automatically means k has to be an odd number. If it is an even number, then k minus 1 is odd, k plus 1 is also odd, product will be odd, and odd by even is not an integer, right? So k has to be an odd number. Okay, let us assume k is 2n plus 1 then. Okay, k minus 1 will become 2n and k plus 1 will become 2n plus 2. Okay, 2n times 2n plus 2 by 4. This 2 and this 2 will get cancelled, so we'll be left with n into n plus 1. This is the condition. M can be such numbers which are in the form of n into n plus 1, where n is an integer. Right, guys? Very simple problem. For roots to be rational, there should be this irrational part cannot come. If this will be rational, when b square minus 4ac is a perfect square. Okay, and if b square minus 4ac is less than 0, then we'll get complex roots, not even real roots. So, for example, if we get something like under root minus 5, that means it is 5i. We'll get roots like 2 plus or minus 5i or 4 plus or minus 6i, whatever, such kind of roots. These are clearly imaginary roots. For real roots, we want b square minus 4ac should be greater than or equal to 0. And for rational roots, we don't want this irrational part. That means b square minus 4ac should be perfect square. So that square root of that is a rational number. Right, guys? Hope you like this. Thank you.